I'm going to ask you to start this video by pausing it and honestly just see how far you can go and then unpause the video when you're ready for me to go over it with you. So the null hypothesis is that the standard deviation is 0.04 or 4%, 0.04, and then the the alternative hypothesis, they want to know if it has moderate risk, which is that it's less than 0.04. So the N, the sample size that they conduct is for 25 months. So the degrees of freedom would be 24. S squared is the sample standard deviation squared. So the sample standard deviation is 0.0301. So 0.0301 squared is, move that over, so 0.000906, right? 1, 2, 3, 4, yeah. 0.000906. And then the null hypothesis squared is 0.04 squared, so 0.0016. So compute the test statistic is going to be to take the n minus 1 times the s squared, which is 0.000906, and divide by 0.0016. So 24 times 0.000906 divided by 0.0016. It's 13.59 for the test statistic. And then calculate the critical value. So let's see. The degrees of freedom is definitely 24. Because it's less, this is a left-tailed test. And a left-tailed test, you have to take 1 minus alpha. So if alpha is 0.05, I'm going to be looking on my chart, which I keep exiting out of, at 0.95 and 24. So I'm going to get a critical value of 13.848. And I'm going to say here, I didn't leave room for the picture, but I could. The left-tailed test, so this critical value is 13.848, and my test statistic is just barely in there at 13.59. So we will reject the null hypothesis. And so that means that there is enough evidence to conclude the alternative hypothesis, which is that the sample standard deviation is less than 4% or is considered a moderate risk.